Welcome. So, we are now in the lesson 28, the simple annuity. Here is our learning outcomes. At the end of the lesson, the learner is able to illustrate simple and general annuities, distinguish between simple and general annuities, find the future and present value of simple annuities, computes the periodic payment of a simple annuity. So for the lesson outline, first, time diagrams. Second, future value of a simple annuity. Third, present value of a simple annuity. And the last one is the periodic payment of a simple annuity. Okay, so let's have our definition of terms. Annuity, a sequence of payments made at equal or fixed interval or periods of time. Annuities can be classified in different ways as follows. According to payment interval and interest period. Simple annuity, an annuity where the payment interval is the same as the interest period. General annuity, an annuity where the payment interval is not the same as the interest period. According to the time of payment. Ordinary annuity or annuity immediate, a type of annuity in which the payments are made at the end of each payment interval. Annuity due, a type of annuity in which the payments are made at beginning of each payment interval. According to duration, annuity certain, an annuity in which payments begin at the end at definite times. Contingent annuity, an annuity in which the payments extend over an indefinite or indeterminate length of time. Term of annuity, or T, time between the first payment interval and last payment interval. Regular or periodic payment, or R, the amount of each payment. Amount or future value of an annuity, or F, sum of future values of all the payments to be made during the entire term of the annuity. Present value of an annuity, or P, sum of present values of all the payments to be made during the entire term of the annuity. So now let's proceed to our topic. So annuities may be illustrated using a time diagram. The time diagram for an ordinary annuity, payments are made at the end of the year, is given below. So we have here a time diagram. So we have 0, 1 to 5 in terms of years, and R represents for the amount of each payment, and N is the number of payments. Okay, so now let's have our first example using the time diagram. Example. Suppose Mrs. Remoto would like to save 3,000 pesos every month in a fund that gives 9% compounded monthly. How much is the amount or future value of her savings after 6 months? Okay, so we have here our given. R is equal to 3,000 pesos, the periodic payment or the regular payment. T represents for the time, it is 6 months. And our interest rate per annum, or the I raised to 12, is equal to 0.09. From 9%, we convert it to decimal, so we have 0.09. And M is equal to 12 since it is compounded monthly. I is equal to 0.09 over 12 equals 0.0075. Now let's find the amount of future value at the end of the term f. So, okay, let's have our solution. So, first step, illustrate the cash flow in a time diagram. So, we have here the payments and the periods. So, since the term or the time is 6 months, so we have 0, 1, 2, 3, 4, 5, 6. Then the periodic payment is 3,000 pesos. 3,000 pesos monthly. So, Mrs. Remoto needs to pay 3,000 pesos for every month. So, let's go back here. Using the compound interest formula, that's the future value is equal to the periodic payment quantity 1 plus I, that's the interest per period, raised to n minus 1 all over I, where n is the number of periods, where n is equal to the compounding period times the time. So to solve now for the values of each month from the formula, okay, here. Second step, find the future value of all the payments at the end of term. T equals 6. So we just need to subtract 1 from n. So for 1 year, that's the periodic payment. That's 3,000 times 1 plus the interest rate 0.0075 and again n minus 1. Since n is equal to 6, so minus 1, that's equal to 5. That's why we raise it to 5. Okay, then for the second month, solve for n minus 2. So we have P, that's 3,000 pesos, times 1 plus 0.0075 raised to 4, because 6 minus 2, the answer is 4. And next, same procedure for the third month. So 3,000 pesos times 1 plus 0.0075 to the power of 3, because 6 minus 3, that is 3. Next, we are now in the fourth month. So 3,000 times 1 plus 0.0075 to the power of 2. So 6 minus 4, that is 2. And for the fifth month, we have P, that's 3,000 times 1 plus 0.0075 to the power of 6 minus 5 is equal to 1. And next, to the power of 1. And next, for the last month, the sixth month, that is 6 minus 6 for n, so this becomes 0. So therefore, for 6 months, that's 3,000, because any number raised to 0 is equal to 1. So this becomes 1 plus 0.0075 to the power of 0. So this is now the cash flow. Then, to find the future value, we just need to simplify these equations. So for step 3, let's add all the future values obtained from the previous steps. So 3,000 is equal to 3,000, that is for the 6th month. Next, for the 5th month, 3,000 times 1 plus 0.0075 raised to 1, that is 3,022.5. Next, for the 4th month, 3,000 times 1 plus 0.0075 raised to 2, that is equal to 3,045.169. For the third month, 3,000 times 1 plus 0.0075 raised to 3, that is 3,068.008. And for the second month, 3,000 times 1 plus 0.0075 raised to 4, that is 3,091.018. So for the first month, 3,000 times 1 plus 0.0075 raised to 5, that is equal to 3,114.20. So overall, the total for our future value is equal to 18,340.89 centavos. Thus, the amount of this annuity is 18,340 and 89 centavos.
Now let's have the amount future value of ordinary annuity. The future value F of an ordinary annuity is given by future value is equal to R times the quantity 1 plus I raised to N minus 1, where R is the regular payment, I is the interest rate per period, N is the number of payments. Let's have an example for this equation. Example, in order to save for her high school graduation, Mori decided to save 200 pesos at the end of each month. If the bank pays 0.250% compounded monthly, how much will her money be at the end of 6 years?
So since the payment interval is each month and then compounded monthly, so they are equal. So this situation illustrates simple annuity.
So here are the given. Regular payment is 200 pesos and then the interest rate is 0.250%, then will be 0.0025. We just convert it to decimal and the term or time is 6 years. And time is 12 since that is compounded monthly. Then Rn equal m times t or 12 times 6. That is 72 per total numbers of period. And I R over M, that is 0.0025 by 12. So we have 0.0020083. Find F. So here is a solution. And then the formula, we still finding the future value. So using the formula, let's just substitute all the given values. To our formula, future value is equal to 200 times the quantity 1 plus I. 0.00020083 raised to 72 minus 1 all over 0.0002083. So if equal 14,507.85. Hence, Marie will be able to save 14,507 and 85 centavos for her graduation.
So now let's proceed to the present value of an ordinary annuity is given by present value is equal to R times 1 minus the quantity of 1 plus I raised to N all over I, whereas R is a regular payment, I is the interest rate per period, and N is the number of payments. To get the present value of this amount, we use the formula P is equal to F over the quantity of 1 plus I raised to N. So now we have a problem here. So the cash value or cash price of a purchase is equal to the down payment, if there is any, plus the present value of the installment payments. So here is the example. Here is the example problem. So Mr. Ribaye paid 200,000 pesos as down payment for a car. The remaining amount is to be settled by paying 16,200 pesos at the end of each month for 5 years. If interest rate is 10.5% compounded monthly, what is the cash price of his car? So we have here the given. So the down payment, Mr. Ibaya paid 200 pesos as the down payment for a car. So R for the regular payment or the periodic payment is equal to 16,200, and the interest rate interval per annum or the I raised to 12 is equal to 0.105, so the interest is 10.5% compounded monthly, and convert it to decimal. That's why we have here 0.105, and we have the M is equal to 12 since it is compounded monthly. So I is equal to R over M. That is, let's substitute the given. 0, the R is equal to 0. This is the rate. 0.105 all over 12 is equal to 0.00875. And we have our time. This is 5 years. Then the N is equal to M times T. Let's substitute. M is equal to 12 and T is equal to 5. So 12 times 5 is equal to 60 periods. So now let's find the cash value or cash price of the car. So here is the solution for the problem. So the time diagram for the installment payments is given by P is equal to blank. So we are going to find that. We are going to find the P. So we have here the period and the payments. So the period is 0, 1, 2, 3, and this is supposed to be 1 up to 5, because we have our time or period is 5 years. So in every year we have the installment payments. So the 60, that is the equivalent of N. So the present value of this ordinary annuity is given by P is equal to R 1 minus the quantity of 1 plus I raised to N all over I. So let's substitute the given. So P is equal to, we have here 16,200 as the installment payments or the periodic payment, times 1 minus the quantity of 1 plus 0.00875 as the interest rate raised to 60, that is for the N, all over 0.00875. So that is 753,072.20. So the cash value or the down is equal to down payment plus present value equals 200,000 plus 753,702 and 20 centavo. So the cash value is equal to 953,702 and 20 centavos. So the cash price of the car is 953,702 and 20 centavos. So now, in solving for periodic payment or of an annuity, there are different formulas you need to remember. First, if you are looking for the future value with a given regular payment, you are going to use the formula future value equals regular payment times the quantity 1 plus interest rate per period raised to n minus 1 all over the interest rate per period. And if you are looking for regular payment with a given future value, let us have regular payment equals future value over quantity 1 plus I raised to n minus 1 all over I. And if you are looking for the present value with a regular payment, let us have present value equals regular payment times quantity 1 minus quantity 1 plus interest rate per period raised to negative n all over I. And if you are looking for the regular payment with a given present value, we are going to use the formula regular payment equals present value over quantity 1 minus quantity 1 plus interest rate per period raised to negative n all over I, where R is the regular payment, P is the present value of an annuity, F is the future value of an annuity, I is the interest rate per period, and N is the number of payments. So let's have this example. Paulo borrowed 100,000 pesos. He agrees to pay the principal plus interest by paying an equal amount of money each year for 3 years. What should be his annual payment of interest as 8% compounded annually? So here are the given. So P is equal to 100,000. This is the principal amount. Then the interest rate is equal to, since it is 8%, we convert it to decimal, so that is 0.08. And then we have M is equal to 1, since it is compounded annually. And we have the I, it is equal to 0.08 because the interest is 8%. Then our time is 3 years. N is equal to M times T is equal to, we substitute it, M is equal to 1 and T is equal to 3. That is 3 years. So 1 times 3 is equal to 3 periods. And now we have the solution. The cash flow of this annuity is illustrated in the time diagram given below. So our principal amount is equal to 100,000. So we are going to find the value of R. So we have here the time diagram, which is the period 0, 1, 2, 3 because the time is 3 years. Then the payments, we're going to find the value of R. So since P is equal to R, regular payment equals present value over quantity 1 minus quantity 1 plus the interest rate per period raised to negative n all over I. So let's substitute the given into the formula. So for the present value, it is 100,000 pesos. So over the quantity of 1 times the quantity of 1 minus the quantity of 1 plus 0.08 raised to 3 all over 0.08. So that is 38,000 803.35. Thus, the man should pay 38,803 and 35 centavos of every year for 3 years. So that's all. Thank you for